Hey guys, in this video we're taking a look at sketching cubic graphs. So, I think in all of these examples I'm going to give us the cubic in factorised form, so we don't need to faff around doing that. You won't always be given them in factorised form, you will need to factorise them yourself. If you want any more practice on that, I did plenty of it in the quadratics and cubics playlist, so go back if you still struggle with that. So, before we get going with sketching the graphs, I need to explain the different types of root that we might come across. So, cubics will always cross the x-axis at least once. They have potential to cross the x-axis at 3 distinct or different places. Now that happens when we can factorise them into the form x minus a times x minus b times x minus c, something like that, where we get 3 distinct factors. So something that factorises like this would cross the x-axis at x equals a, x equals b, and x equals c. Okay, then we've got two types of repeated root. So a repeated root comes from when you have, say, two repeated factors. So, for example, we could have here x minus a times x minus b squared, which would mean x minus a times x minus b times x minus b. So x minus b is a repeated factor, which would give us a repeated root. Now it would give us a double root. It's double because it's squared. Now when we have a double root like this, at this point, so here, when x is equal to b, the graph does not cross the x-axis, it just touches it and then turns around. But here it will cross at x equals a. But again, at x equals b, it will touch it and then it will turn around and go away again. The other type of repeated root that we have is a triple root. So a triple root comes from when you have something like x minus a cubed. So it's called triple because this factor is cubed. So that leads us to a triple root. Now what happens at a triple root is the graph crosses the x-axis at this point. So here, when we have x minus a cubed, the graph crosses at x equals a. At that point, and only at that point. So, those are our three different types of root. Now we're going to have a look then at sketching some graphs. Okay then, first example, so y equals x times x minus 3 times x plus 2. So, usually we would need to work out what the y-intercept is, but here we already know what the y-intercept is. So, remember the y-intercept is just a constant number at the end on its own with no x's attached. What's going to happen here though, if we were to expand the two brackets, that would give us a quadratic with a constant of minus 6, but then that is being multiplied by x, so we would have a no constant term at the end of the cubic if we expanded this all out, which means the y-intercept is 0. So, that's the first thing. The y-intercept is 0. We would also need to know whether we've got a positive or a negative x cubed term. So, x times x times x would give us positive x cubed. So, we've got a positive x cubed 10. So that means our graph starts on the bottom left and is going to finish up on the top right. That is governed by either the positivity or negativity of the x cubed term. If it's positive, it starts bottom left, ends top right. So, we also know from the factorised form are three x-intercepts. So, the factor of x at the start gives us x equals 0. X minus 3 tells us x equals positive 3. And then x plus 2 tells us x equals minus 2. So we've got all the info we need to be able to sketch this bad boy. So remember, sketches don't need to be deadly accurate, they just need to show the important information. So, we know the graph is starting on the bottom left, cuts the x-axis at minus 2, and then at 0. So, it's going to look something like this, and then it's going to get down, and then it cuts the x-axis again at x equals 3. So, we just need to label these points. So, this guy would be 3, 0. This guy over here would be 0, 0. And then this guy is minus 2, 0. Like that. So there's a sketch of our graph. Later on, when we come to something called differentiation, we will also be able to find the coordinates of the peak and trough of the curves. So this point here and this point here. So we can't do that yet. Well, we sort of could, but we're not going to. It's a lot easier when we know how to differentiate. So we will be coming back to cubic graphs even later on once again. For now though, that is that graph sketched. Okay, example number 2. So y is 2x minus 1 times x plus 1 times x minus 5. So, first of all, let's find the y-intercept. So the y-intercept is the three constants multiplied together. So, minus 1 times 1 times minus 5. Now that is going to give us positive 5. So there's our y-intercept. Let's check whether the x cubed term is going to be positive or negative. So 2x times x is 2x squared, times x is 2x cubed. So again, we've got positive x cubed term. So just like the last one, we're starting in the bottom left and ending up in the top right. Now we just need the three solutions. So remember, to get the solutions, you set each bracket equal to 0 and then solve for x. So 2x minus 1 tells us x is equal to 1 half. X plus 1 tells us x equals minus 1, and x minus 5 tells us x equals positive 5. Okay, I got all the info we need. Let's sketch him. So, okay, so again we're starting bottom left. Now the first place that we hit the x-axis is at x equals minus 1. So we're going to come up, hit the x-axis at minus 1. And then we are next hitting it at x equals positive 1/2. So it's going to go through the y-axis like that. So then it hits the x-axis at 1/2, and then again over here at x equals 5. So just label the points. This is 5, 0. This is 1/2, 0. The y-intercept, remember, was at 5. So this point up here is 0, 5, and then the guy on the left is minus 1, 0. I like that. So there he is, sketched. Okay, last one for this video then. So if anyone wants more examples of sketching cubics, let me know down below in the comments. Don't forget to give us a thumbs up, get subscribed, all that malarkey. So, we're ending on a bit of a friendlier one here for once. So we got y equals 2 minus x all cubed. So, what's the y-intercept going to be? Well, we would get that by doing 2 minus x times 2 minus x times 2 minus x. So in terms of the constant at the end, that's 2 times 2 times 2, which is 8. So our y-intercept is 8. Now, are we going to get a positive or negative x cubed term? Well, we would do minus x times minus x, positive x squared, times minus x, negative x squared. Okay, so we got a negative x cubed. Negative x cubed this time, and there is only one root. It's a triple root. So that is going to be, well, if we set 2 minus x equal to 0, we get x equals 2. So, let's sketch him. So, it's got a y-intercept of 8, crosses the x-axis at 2. So, he's going to look something, starts in the top left because of the negative x cubed. He's going to look something like that. So this point here is 2, 0. This point up here is 0, 8. So that's all we need to label on this guy. Okay guys, that's it for this video then. As I said, let me know if you want any more examples. Next up, sketching cortex. Good times.